the founder of the school. I started it for my own kids when they were little, and main thing that I wanted at that time to find out is how to engage them, how to teach math in a way it's fun. And of course, I researched a lot of games, or some of them as we went and learned math came up, and we created them together. So some tricks and games that I'm hoping to tell you guys today are in fact very simple and perhaps somewhat known. Some of them are on our own inventions. So I hope that everything will be interesting and useful to you. Aprana, Connie, um, would you mind telling us what age kids do you have? And we have another visitor.
5.
5. And Aprana, or you guys can put it in the chat if it's better, so I know how to address better what we're doing. Only 1, 5, any older kids? Um,
Yeah, my son is 4 years old, but he's doing a little advanced math like the 5 year and 6 year old. So I thought he might fit
okay.
into this topic. Yeah.
Yes, and we have a new visitor, Am. What age kids do you have?
4 and 7.
4 and 7.
He wrote.
Okay, so we have older kids. So I actually was planning um, to talk a little bit more to to cater more to the older age. So because we did a presentation, this presentation about younger kids, but I'm guessing with completely different crowd. None of you guys have been here a couple of weeks ago when we did the first time, so I can review some of these games that fit your age groups, which we are at majority, the 5-year-olds, and then talk about how do you convert the same principles for and play similar dynamics games, but with older kids, which will fit the 7-year-old sibling that has. So very, very short. Last time we did a long discussion about why you play games and how we, I think, best teach our kids. And in my opinion, it's any way you can let the kid discover and do the learning by as much as possible themselves would be best. And to achieve that, all we need to do is ask the kids the right questions. So ask something they are ready and able to answer at this point, and let them think about it, and help only if needed. Don't volunteer your own thoughts ahead of time. And another thing that I wanted to shortly mention is really why are we talking about playing games? And the most obvious question is answer is because it's fun, and uh, and but the many benefits that we can get from playing uh, is not just fun. Play is our most natural way of being motivated to do something. It can have stories. It can help us think of whatever we're doing as an experience, an adventure. We can use tactile games. We can involve more than just one sense. We can be endlessly challenged and practice skills that are social, not just problem solving, communication, interactions. It's all very, very rich experience. So this is game as a tool, and we can use it to have fun, but we can also use it to play. Um, if you guys would like to give your own thoughts on these two subjects, one is why do we ask questions and not just tell our thoughts ahead of time, and the other one is why play. I'd love to hear your input because I also want to learn, and it's, you know, one mind is good and many minds is much better. So um, anyone, any ideas? Why would you rather ask questions?
Well, when you ask a question, you stimulate your mind. You basically makes your brain tick and kind of like get things going
Yes,
there.
and I would even say that for me, thinking about the right question makes the game more interesting, or the
Mm.
conversation, even when I know the subject, when I see the kid and I want to teach him something and I want to adjust, I need to think what kind of questions I want to ask this specific game. It will make my brain rolling as well and make it something new every time. Um, any volunteers about games? Any other things that I haven't said? And I didn't say it all because I just wanted to make it brief. Did I miss anything that you
No,
think of?
no,
Yeah, but
that's
I
good.
think
Yeah, let's
the,
start
the main the main
playing.
thing is games is really motivation. And same way as last time, I would like to start with actually, you know what, um, with a math trick, but I'll start with a math trick and a game, a little bit different. We'll save this math trick for later, even though I already previewed it. Let's talk about this game, and I call it Catch the Thief. Catch the Thief is just dynamic of a game. I like when I teach, especially very little ones, to tell a story behind any activities we do. So a story here would be, and I'd like to have the parents try pretend being kids now, uh, and if possible participate. If not, we'll have Ira be the kid. Um, so I'd tell you guys to close your eyes because it's night time, and go to sleep, because that's what we do at night time. And imagine that a thief might come to your house and he might steal some of your toys, but you can catch the thief. If when you wake up, you can tell me what he stole. So here, a setup for a game is a set of dominoes. Usually, you don't have to start when the dominoes are sorted into numbers. Actually, it's with the little ones, it's better to give the dominoes, mess them up, give the dominoes to your kid and ask them to sort into the right slots. Um, and as he goes, maybe talk about what number belongs where and how numbers are made, like 5 is 3 and 4, 6 and 6 and 0, and how many ways are there. Um, and the motivation for doing this activity is because we need, this is going to be our game board, and this is how our game will start. So um, let's say you have sorted, or you have already, oh, sorry, we jumped. Where is that? Sorry, my slide jumped here. Or you have pre-sorted the game because you've done the sorting so many times already, and your kid is only interested in long sorting activity once, and you just want to play the game second time reinforced. So you sort, you make your board game, and you start with telling your kids to go to sleep. So kids go to sleep because it's nighttime, and you know our thief is going to come, and he's going to steal a number of dominoes, perhaps. Um, let's see, these three. Now it's time to wake up and catch the thief. You can also say there's been 3 thieves that have stolen things. So for the young, let's pretend somebody is a 5-year-old. Any of the parents want to unmute and be your 5-year-old? Wake up, it's time to catch the thief. Okay, so for a 5-year-old, I would like to ask, I have a few ways of asking. So I can ask Ira, what number did the thief stole that is less than 4? What domino is
Maybe.
missing there?
Are you talking about the 2?
Um, so you think in the number 2 there is a domino that's missing?
I think so. Well, maybe
But I
1
see
and
one
1.
domino. Oh yeah, yeah, because I see a domino that has 2 and 0, and yeah, probably you're correct. Probably there is a 1 and 1. Let's wait to see if you find all of them. So okay, 1 and 1 is missing. I agree. It makes 2. Now pretend you are a 7-year-old and tell me what is a sum of 2 dominoes that are missing, because I only stole 3 together. Do you know sum is when you add them together? Can you guess? Let's catch that thief.
Oh, so I need to find another one right now and then sum them together.
Yes, sum means adding 2 numbers. So see what's missing. I have 2 more dominoes missing because I
Yep.
stole 3. So I have a domino missing here and I have a domino missing here. Can you add them together and tell me how much they make?
Well, I think 5 and 6, 11.
Oh yeah, there you go. And what domino was stolen that makes 5? What 2 parts? And that's a question that can be addressed better to a 5 or 6-year-old when you're learning numbers, how to break numbers into parts.
Maybe 4 and 1. I
Um,
see 4 and 1 here already.
there
On
you
top.
go. You already have 4 and 1. What else can make 5?
Well, I see 2 and 3. 5 and 0.
Right, 5 and 0. I'm not gonna draw the dots, or actually I can. 2, 3, 4, 5, and nothing. Okay, how
Yeah.
about your last one?
Let's see. So this, no, 5 and 1 I see. 4 and 2, maybe 3 and 3.
Yep, and you're right. You caught the fifth.
Yes.
Then let's return the toys back to the board game, and then we can let our little ones be the GMs of the game, the general manager of the game, and send us to sleep and steal things, but from us. But then I would ask them to make the questions more difficult for us to really solve. So they have to think how to pose the question. So the question about the sum, knowing which sum we stole, he needs to add the numbers before he asks me. So would be a nice way to provoke their thinking when they're making up problems. So first we model what types of questions we can ask if a number is more or less than another number. If a number is a sum of 2 other numbers, you can go to any operations and you can pair up couple numbers, pair numbers, or take 3 numbers at a time, whatever amount of arithmetic fluency your kid has and or you're trying to teach right now.
I
So
have a question,
yes.
like practical question. So if let's say I have a domino at home and I want to
Mhm.
play it with like real dominoes and not, use the devices. So do I need to basically also like print out those numbers as well and sort them out this way? Because it actually helps to have the actual number there for them to count to
Yes,
play this game.
I used to have the physical actual numbers. If you can see, I don't know,
Mm.
this picture enlarged.
Oh yeah.
Um, Kids are sorting them. It's better when they have two visuals at a time, and when we are trying to, let me try to make this picture big, if so you can see.
Yeah, yeah, yeah.
See, there are numbers down there that
Mm-hmm.
they are sorting the dominoes into. We used to call this game, when you have physical dominoes, also parking dominoes game,
Mm-hmm.
because we would set a timer, have a messed up parking lot, and each one would race to park their cars first and make an order in it. So it's another way to set up your board game for the next game.
Oh, that's the
And yes,
perfect boys game.
yep,
Perfect boys game.
yep. Um, so yes, I believe anytime you can um, put a few different visuals, always uh, uh, an, a number, that is how we write a number, and connect it with a quantity. In this case, it's a domino dots that you can count. But here is another example where I can connect a number to a quantity that is a culinary rods tool, or you may be familiar with connecti cubes that attach, or rods of different sizes. That's what they are. So some of them can be blank. I think I have a picture here of blank usinary rods. How they come is different rods of different sizes. And I actually like them a lot because you cannot count them. You may need to estimate, you may need to put them alongside of each other to figure out which number or which color is which number. And um, and again, um, you can play catch the thief here, because let's say in this setting, at this point, I would ask the kids to try to remember all the colors, and maybe not know, think what they could be as numbers, right? They are not sorted, not in a way where it's obvious, or we have a easy way to check which color is which number. Here they are sparse. Maybe we are seeing this first time, but let's try playing a fifth. So you close your eyes, you go to sleep, and then I steal something from you. So look very, very carefully. Try to remember them for 3 seconds. Now close your eyes. I'm going to steal these two. Now wake up. Um, Anybody wants to volunteer? What colors did I steal? Let's try that first. Ira, you're muted. I think you're accidentally muted. Yeah.
Yep. I think I'm missing orange and blue.
Okay. What do you think? What numbers could they be? Can you guess? Can you figure out?
I remember they were long,
They were long.
longer,
Oh, so what do you think? What could be their numerical value?
and maybe 10 and
Maybe
8.
10 and 8. Okay, I'll put your guesses here, 10 and 8.
Okay.
How can you check? Because I stole two. What can you do with the rest of the rods? Let's figure out
Well,
so
I
we
can
can see
organize
which
them.
ones are. Let's do it. Okay, which one do you think is 2?
3 is green.
Okay,
2
3
is the
is green.
red. It's like the one.
Yeah. Okay, 3 is
And then
green. Okay.
purple.
Okay, let me move them around a little bit. So we have space.
Mm-hmm.
Okay, 4 is purple. Um, one sec. Okay.
Yep, and
Well,
yellow conveniently there.
and now we start seeing a
Green.
pattern,
Mm-hmm.
and black, and let's see.
So maybe it was 7. No, actually, maybe I was
Let's.
right.
You were
Or maybe
close.
9 and 10.
9 and 10. Yeah.
Okay.
And any chances? Do you want to guess which one is which?
Maybe I think the orange was longer. So
Yep.
orange was 10, and then blue was 9.
Yes. Let's return it, and I'm gonna mess it up again, and return the rods. Or actually, we're just gonna go. Oh, there they are.
Oh,
Orange was 9 and blue was, and here I have a little solution. So we can see all the rods in order.
nice.
And you can check against that you were right. So, and again, more complex if your child is older, either take a little bit more rods, and you can ask about sums that are missing, differences that are missing, um, uh, of, of the rods that you just lay down. I promised you a trick, but I want to, jumping from one step. We'll jump back to the rods afterwards, because actually for older kids, and we have one in the audience, and uh, obviously the 5-year-olds are gonna grow up into 7-year-olds, and later will grow up into 9-year-olds, and my adult kids may be interested in this domino magic. So I am going to, since you don't have, anybody has a physical domino at home, then they can really quickly go grab and bring it over here. Just say yes in the chat. If not, never mind, we'll do it without. So what I'm gonna do, I'm going to treat a domino as then a 2-digit number, because you guys, we don't have right now a physical domino in somebody's hands that I don't see what numbers are in. So this domino is, for instance, 16, right? And if I flip it, it matters how you flip it. So you should flip the domino this way, it's going to be 36. This way, it's going to be 63. So ask your kid to take a domino, lay it in front of them, and make sure they look at it at the same angle, so one way, and they look at the numbers and they see and they remember what they have. Then they don't tell you, and you are magically going to be able to impress them and guess their numbers, but they have to do some math for it with you as well. So instead of laying down a domino, how about you guys write a number that has 2 digits? Okay, so any 2-digit number. And when I am teaching, I like, and since we are adults as well right now, I like to do things that may help you discover how this trick works. So how about we, as we talk, write down as well what we do in a way of algebra. So look at your domino. What number do you have on your right side? On your left side, sorry. So the left side. So I don't know this number, no, domino. I'm gonna write X instead of it. That's your left. Actually, I'm gonna write L instead of it. That's your left side. So take your left side number, multiply this number by 5. Done. You have a result. Add a 7 to what you get. Do you have a result? Okay. Now, whatever your result is, multiply it by 2. So now I'm going to ask the big kids if this is the right way to write down what I'm doing. Did I multiply my result by 2? No, what's wrong?
No, no, you need brackets.
Right, because I only multiplied 7 by 2 at this point, so be careful. But you don't need the equation because you have the result in your hand and it is one number. I just want us to see the equation and try to figure out why this magic works at the end. So last thing that we need to do is add the number of points that you have on your right side of the domino. So your right side digit of your 2-digit number. So add another, the right side. So I'll use letter R for it. Done. You have the result.
Mm-hmm.
Now, how much do you get? Please do tell me that.
I got 38.
Um,
No.
So yep, you got 38. So, well, your domino should look like this. 3 dots and 8 dots on the other side. That was your original number.
8, but there's no 8 dots.
There is no 8 on the domino, yeah, because we don't have dominoes with us. Right, so you chose, and I say chose a 2-digit number. You chose a number. There is no 8 in dots. Well, there are sets of dominoes where you have more, but we'll make up 8. So I might have warned you 1, 2, 3, 4, 5, 6, 7, 8. So how come magically you had domino of 3 dots on the left and 8 dots on the right? These are the numbers that you started with. I didn't even know them.
Well, I actually started with, maybe I did the math wrong, but I started with 24.
With
2 and 4.
24.
Yep.
Let's see where I have the mistake. So let's I might, let me see, maybe I am mixing up something. Anybody did the same exercise that Irina did right now? Did you guys, anyone was writing out and can help us with a different set of results? Connie, we have something in the chat. So you had 2 and 5, and the final answer was 39. 4 and 7. What was the final answer for It should have been 47. And for 2 and 5 should have been, well, let's see what's not working with my formula. What am I doing wrong here, and why I am thinking it should work? Because maybe I forgot some stuff. At 34 for 2 and 5. Okay, let's do some investigation and check what's going on. Okay, so I want to actually just erase under, and if I want to, this is a big equation. If I want to simplify it, what do I want to do with it? How do I want to look at it? Oh, I know what I did wrong. Okay. Can I get a second chance?
Yes, let's do it.
I know what I did wrong. Okay, but
so choose
I also yeah, of course, choose new numbers. Okay. Give me a second, just choose easy numbers so we go fast. Okay, so okay. I'll walk us through the steps. I know what I did wrong. Okay, and I'll erase here. So choose a number. multiply it by 5, add 7 to it. You mean your left side of a number. Now double the result. And add the right side to it. And yeah, that's okay. We have a message. Let me answer. So are you guys ready with your results? Don't tell me. So after you're at the right side, let's do this. Take away 14 from it before you tell me anything. So take away 14 from whatever you got. Do we have a result? Anyone? You can put them in the chat. So your results should be now the left side of the domino and the right side of the domino. Your that worked. And Ira, you're muted right now. Yes.
Sorry. So I subtract for, so the formula is still correct, right? It's L.
Yeah, the formula is
5 + 10.
correct. You need to just subtract 14. That's the little part that I forgot. But
oh, okay. Okay.
so for Connie, it worked. And if you tell your kid the number, you'll be able to just tell them, yep. And for Apranas, it worked. And Ira, I hope it worked, right?
Yeah,
You should
34.
get there, and it was your original number, right? After you subtract 14.
Yes. Yes.
Okay. So
awesome.
we just did a lot of math practice, all of us, to check a magic that apparently works. Why do I do these random operations and get the numbers that are on the domino in my 2-digit number? Any one of you sees it or not? Say no, please, or say yes.
Nope, I don't see it.
Why doing this to the number, to two numbers that were originally placed as a 2-digit number? That's the trick. The domino was viewed as 34, right? But you did something to the left, you doubled it, you did something to the right, you subtracted 14 and you get that back, you get 34 back, even though you worked with digits separately. So it does look like magic, but it's not really. So I want to show, using this example, since this is not kindergarten math, it's not very much more, it's a little bit of algebra, so maybe 6th, 7th, 8th grade math, but you guys are not knowing how it works, I hope, because then it's here would be my chance to show you how do we guide a person who doesn't know how something works to discover the solution. So let's do it. Anybody else besides Ira wants to volunteer? Oh, I want to clear the board and make it here a little bit bigger. So, okay, Ira, you get to be the child.
Okay.
Let me clear this. Okay, so we need to remember to do -14. Put it here. Okay, so let's rewrite this equation. So it looks simpler. And left and right were my two original digits, right? My number looked like this. Let's remember that as well. So how would you open a parenthesis? Because it looks complicated. I don't understand why it works. Maybe I want to simplify it. Can you tell me what to do if I want to write it simpler?
Uh, well, you can multiply the two. So let's say 10L plus
Mm-hmm.
40, plus
Yeah,
14 plus R minus 14. So you basically subtract the 14.
right. So you have 10L,
10L,
you add 14 here, and later,
you
like it
subtract it.
looks, yes, and later you take it away, plus R, and you take it away. So that's a very common trick when you add something and you take it away to create things you need, but to keep the expression preserved. Okay, what are we being left with? What is 10 times L plus R? How does it get connected to a two-digit number? Your L was the number of dots or the digit of your two-digit number. Your R was the digit of the two-digit number. How do you read your two-digit numbers? Let's say you have a 2 and a 3 or a 23. How do you write 23 in another way? What is 2 really?
Oh, multiple 10. Oh, that's cool.
2 is 2 tens. So if you have a digit and you don't know it, the only way to write the value of the number is say I have 10 of those digits. 10 times the number of dots plus the number of units or the ones. So that's why it works. And that's how the equation was created. You can look at this process now going backwards. You have a two-digit number. You want to turn it into some mystery magic thing. You go backwards at how you write your number as how do you say, algebraic expression, and you add some distraction to it that hides what it was before and makes it much less obvious for us to figure out what's inside. Um, so that's a short, of course, operations of multiplication, probably second grade. So 7-year-olds, you can talk about times 5 by doing times 10 and halving, and doubling and halving is the first thing we usually learn how to do, which is pretty easy. So it should be attainable, if not when they grow up to it. So um, let's get back to playing a little bit more games of either thief. I'll go a bit quickly here on another way of setting up the thief game we won't play. So these culinary rods that have different lengths can be used to learn how to break a number into parts. So you can have your kid make the house of 10 before you play thief with it, and you steal things and then return them according to if the numbers were named correctly. So of course, making the house or building the house, you will have to put in um, rods in the right way. So all pairs that make 10. You can set up more than one house and then steal more than one thing, and the child will have to tell you how much was stolen from which house and what makes 6 and what makes 10s and in which way, and take turns in doing that. And for a more challenging, let's actually switch again. You can make a staircase of these rods going up to I wouldn't go more than 20. It's actually more than enough, even if we want to um, work with first, second graders and we want to practice some two-digit numbers and addition and subtraction. And I will use this setting to talk about another dynamic. So this was a fifth game where you just steal rods in either random way or here you go. This is randomly. You can just steal some numbers and ask them to guess what's missing, and they see the others and they can guess. You can steal only the odds, only the evens. We have a message in the chat. Yeah, thank you. I love the Cuisinary rods. Aparna said that she loves the Cuisinary idea. So the story that you can use with the staircase is that we need to go up and down. We need to, when we play or when we are catching the thief, to catch the thief, you need to tell me which holes did he make for you to fall in. Uh, um, wait, let me make some holes. So here um, I'm making, I think, even number holes. I'm not sure. Yep. So when you are a kid, you can ask them, imagine you're at the beginning of the staircase, you need to climb up, but don't fall into the holes. So jump over and tell me which numbers you're jumping on. Or jump over, but don't tell me the numbers, tell me the holes. Go down and go down in jumps if you took over his holes. Or now, last session, we had a really, really great idea given by another parent that participated, and now I'll forever be using that. It was inspired, oh, sorry, by her child usually played with dominoes. Not dominoes, sorry. What are the building blocks called? Legos. And he would put together different sizes or different towers, but he would pretend a one Lego block is a 5, and then when he puts 2 of them, it's a 10, and 3 of them it's a 15. He just loved keep counting basically with this dominoes. So really nobody told us that this little block is 1, right? So, and that's the beauty of asking questions. I just asked parents in the last session, what do you think these numbers could be? And somebody said, well, my child plays with this Legos and he makes them whatever he wants. No, but there's no label on the number. So you can say it's a 5. What do you think is this one? It's exactly how much more, right? What is the next one? It's exactly how much more. And if we don't see, we can measure or we can compare, right? How many white ones go into the red? We are adding by 5. So for the more complex one, then fifth becomes not very easy and intuitive because you have make it timed, make it fast, steal this much and ask how much was stolen when the white one is 5. Now, who goes there first? Do you guys want to try? How much together was stolen when the white one is 5? It's not that difficult because you know these big numbers. Do we want to put some answers in the chat? Or so, okay, should I torture you or not? I'm not. Okay, I'm not gonna wait for an answer. You're muted again. I don't know if you want to talk or just laugh. Okay,
No,
but
stop
anyway,
torturing us.
yeah. So this 9 was 9 times 5, right? You can talk about 10 times 5. That's always nice. That's 50. and that's another 50, and that's 100. There was another 10 close to us, so 150. And then how many fives do I need to discard? There's one missing here, and there is, well, let me put them back. Wait, sorry. Yeah, so now we can visually compare. So there is one missing here, there is one missing here, right? So I only need to, from 150, I need to discard these two fives, right? And 5 make a 10. So yes, so these huge long rods, the 19 fives and 9 fives make together 160, which we also can check, because 19 and 9 is what? 50, 50, correct, 10 times 5. I'm just checking myself. So 19 and 9 is 28. If you do 28 times 5, and we can do it by 28 times 10. That's easy. And then we can split it in half. So something is not working. What math mistake did I make? 9, 9, 18, 10, 28.
Well, 150 minus 10 is 140.
Yes,
No?
sorry. Yep. That's my dyslexic brain. It thinks one thing and then it does the other one. Have you guys ever seen kids doing plus instead of minus? And then this divide by 5 is 140. Now it's good. Yay. And I always, how do you say, my excuse, or my excuse phrase is that I know how to teach. I don't know how to count. But I can teach you to do it. Okay, so this is a more complex thief game for bigger numbers or older kids, and they still will like to do it. It's much better than doing a lot of dry worksheets, is doing exercises with these numbers. The best thing that I like about the Cuisinart rods, that they visualize the Gauss sums in the best way known to me so far. And if you guys don't know what are the Gauss sums, these are these things. And let's talk about Gauss sums, but playing another game dynamics. So we've talked about stealing things from our kids and making them return them by telling us what we stole in this way and another. This game dynamic I call IC10, and perhaps it's very, very similar to the set game if you are familiar. As soon as you see something that was declared by some rules that you're looking for, you scream set. And here, as soon as you see 10, you scream 10 first, and you tell me which numbers you saw that make 10. You can, of course, play IC5, you can play IC3, but it's too easy. And you can play IC any number, 21, and you can play it with rods, you can play it with number cards. We'll go over it a little bit with different types of number cards in different settings, and with regular playing cards. I don't know if I have a picture of regular playing cards, but anywhere you are, it's always easy to have playing cards in your pocket, and they have numbers. But let's talk about these guys. So do you see 10? Let's play IC10. Which color does it have? Mm, anywhere? Let's actually keep only the big stairs. The little
Yeah, I see
stairs.
bottom left. Bottom left.
Bottom. Wait, which bottom left? So where do you see then? Like,
Um,
except for the.
well, it's 1, 3, 4,
Ooh, one,
3, and
three,
4.
four.
So
So
the
you.
white, red, and green and purple on the bottom left.
Ooh, it's a cool theme, a complex one. Let me move some stuff around so we can bring up. So you want to take one. I'll
Yep.
use.
Well, you have an example on
Again,
the
yeah.
bottom left, on top of the EMC school. W.
Oh, yes, you were talking about this one.
Yes.
One, 1, 2, 3, and 4. Yeah, that's a 10.
Yeah.
We
Okay.
can.
Whew.
How did you see that 10? Yes.
Well, I actually
Did you
tried to
just add
figure
them
out.
up?
I actually started counting backwards from the big guys, like 4 and 3, and then
Uh-huh.
the 1 and 2 were easy to complement it. So I counted
Uh-huh.
7 first, and then plus 3.
Yeah, we can try to see if there is a pattern, and kids really usually are very good in looking and finding patterns in the numbers that we have here. Maybe let's look at all the little staircase, how they go. How many do you have here? Just one, correct? Then
Mm-hmm.
the next steps, how much is this? This one is 10.
4. 4
And
steps.
it is 4 steps, and it is 10. How much they are together? You add 1, 2, 2, 3 plus 3, 6 plus 4, 10, right?
Mm-hmm.
And here, how much do you have? 1
3
and
and
2,
2
3,
2
and
steps.
here, right? And then 3 steps is
6. Mm-hmm.
6, 10. 5 steps is you add another 5
15.
to what you had before, 15. 6 steps, you add another 6 to what you had before, right?
Mm-hmm.
So 15 and 6,
21.
21. Okay. And I'll add the last one. You add another 7 to 21 and you get 28.
Oh, that's cool. So they are all adding 2, 3, 4, 5, 6, 7. That's the pattern.
Yes, and that's because we just add another block a little bit bigger than the one that was
Mm-hmm.
added last. You add 2, 3, 4, 5, 6, 7. So, and these numbers are called triangular numbers if you flip them, or even if you look at them like this, they right now look like right triangles turned this way. They are shaped in a way of triangles. You can draw the same numbers using dots or balls. Let me try making this fat balls. If I put 1, then under it I put 2, then I add 3 more, like pyramids, and then I
Mm-hmm.
add 4 more, and I get those triangular numbers, which count. What do they count? Actually, I was doing, let's do some text here. Let's say in the last pyramid we added 1 plus 2 plus 3 plus 4, I plus 3 plus 4 plus 5, and we went up to 7, right? So this type of sum is called Gauss sum. The reason it is called Gauss sum, and it's another story that I like telling kids. And again, if you have a story about what you're teaching, that's the best. If you don't have, make it up or look it up. So the story about Gauss, and that's why these sums are called Gauss sums, is that he was a little kid, very smart, very impatient, and very annoying to his teacher. Obviously, his math teacher, because he would get everything first and then he would get bored sitting in class. So one day, his teacher said, I have a task for you. and I hope it will keep you busy for a little bit or for some time. And he was hoping to keep him busy for as long as the lesson goes. So take a paper and do this. Do 1 plus 2 plus 3 plus 4 plus 5, and don't stop. Plus 6 plus 7 plus 8, and add all of these numbers until you get to, let's say, 100, if we are talking about a 5 or a 6-year-old. And I do this exercise with kids. So I tell them, let's try adding. Do you want to do it? And they usually don't really. They can add the first couple and have patience. Some of the kids do really like adding and go up to some number. But here we go up to 20, right? Let's say we make our problem even smaller. Let's go up to 20. Let's try to see what little Gauss did, because he came back to his teacher after 5 minutes and say, I'm done. He said, I'm done, and he put a number that was correct. So which way did he not just figure out, and he wasn't adding, but he found a convenient way to add these numbers so that he was fast and he had almost nothing to do and was ready with his answer. And we have somebody, time's up. Oh, okay. Yes. So let me just spoil the, do you guys want to hear? Well,
Yeah.
which numbers are easy to add? Like not 1 and 2, obviously, but 1 and maybe another number. Who do you want to pair it up? Organize numbers in a way that they will add nicely. How about 1 and 9?
Mm.
Or 1 and 19? And we'll make a 20, right?
Mm-hmm.
Uh,
2
oh,
and 8.
actually, 2 and 8, right? So what Gauss did, I will do it with a small sum, and you can do it, and it's a proof of a formula of arithmetic sum. He took this, these numbers, all these numbers. He copied them again and added them in an opposite way. Oh, I need some more, like this. Will they fit? There you go. So, and in case with 10 numbers, it will look the same. So here we're doubling everything we have, but we are adding the first and the last. So in case of 1 and 100, it will make 101, right? But how many of them do you have? You have 100 numbers. How many pairs did you create? Well, how many numbers? As many pairs, because we doubled them. 1 and 1, 2 and 5, 3 and 4, or 1 and 20, 2 and 19, making them all nice numbers equal to the same thing. And then you just half it. So you take 101 100 times in this case, and you half it. So you can half the 100, you actually have 50 times 101, and that's for big kids. So 5050, that's 50 times 101. That's for the big sum. But for the little one, there is even better way without making a rectangle or without doubling, just making tens for the very, very little. Just make all possible tens and count them. So tens or 20s, like this or like this. And you'll get to the same result. That's it. Since the time is up, I hope you guys enjoyed.